set up. And I set them up beforehand, but then something went wrong. Gotta do it all again. Okay, and we're recording. Okay, so welcome everyone. Let's see. My lighting is not great, but who cares about that, right? Okay, were there any other questions? So some people had kind of a difficult time with parts of the quiz that weren't totally clear, and some people weren't able to take it yet. So I will open it up for a few more days, and then on Thursday we can go over the quiz, okay, just to make sure. Now the one that we were talking about, I think it was just a pretty straightforward. You know, if you look at these, let's see, if you look at the argument forms that we went over, you should be able to sort of start being able to look at the arguments as, you know, if A, then B, A, therefore B. That's sort of a format where you don't necessarily need to look at what the sentences say, except for those things like if then. And then you could just simply substitute the sentences for A's and B's, and then you can look up, you know, so I'm getting to those argument forms. Okay, did everyone see that? So Alyssa is recommending, you know, if the textbook that we're using, if it's maybe the way it's written, it might be more confusing for some people. She's recommending a book by Michael Goodman. I don't know the book, but I know Michael Goodman. He was a good professor. He's a smart guy. So if that book is helpful for some reason, you might be able to find a cheap copy at it looks like at Tin Can Mailman in Arcata. You know, why not? It would help, you know. But all this stuff is pretty standard, so you're going to find the same sort of stuff in every book. It's just that the way they explain it might be slightly different. Yeah, and you can also, you know, I hope you're watching the videos that I'm putting up, not the videos just of myself, but other people explaining how to do this, the propositional logic stuff and the argument forms and all that. Okay, I'm slowly getting to. So we're going to look at those in a second. But this is what I was talking about. So for the quiz, for example, if you just had this handy little chart, and then if there was an argument that said, what was it? If you had supported me, I would have succeeded, or something like that. I didn't succeed, therefore you must have not supported me. Right. So you should try to figure out what the argument structure is there. And if I said it correctly, then the argument structure is if A, then B, not B, therefore not A. And then you could just quickly see, okay, let me look that up in the chart. That's a modus tollens, and that's valid. Now, I don't remember, let's see, Rachel, right? Rachel, you brought this up. I don't remember what the actual argument structure is. It's hard for me to quickly go to that quiz. But that's the sort of thing you could do and think about. You know, what format does it fit into?
Yeah, I don't want to give away, like, answer, you know, like, but like I really felt like I put in the right answer, and
double check.
I thought it came out wrong.
Plenty of times. I'm embarrassed to admit it, but you know, when I create a quiz, even if I know the right answer, sometimes I might just accidentally say true for the wrong one. So let me double check to make sure. I mean, that would be awesome, right? If you got it right.
And now I'm like questioning my memory too, and I'm like, I don't know. I just like I guess I should just like look it over and like email you or talk about it on Thursday, and I'll double check. But like, okay. Yeah, I just really struggled with it. But yeah.
Okay, well, yeah, maybe it'll become clearer as we proceed. You know, as we go over this more. We're gonna go over those previous ones. I'm gonna fix my window really quick and close it. It means I have to go under my desk. Very awkward, but I'll be out of view. There we go. So graceful, isn't it? Teaching out of your attic. I heard somebody else. I heard that airplane flying over through somebody else's mic as well.
Mine.
Yeah, it's pretty funny. Okay, so were there any other sort of general questions or concerns about the pace of the class? We are a little bit behind, but I'm not too worried about it. Guess we might be coming up on midterms already, which is crazy. But coming up kind of soon. But I'd like
So far it's good.
what's that? So far so good. Yeah. So I'd like to finish propositional logic before we do the midterm. Okay. So propositional logic will basically just go over what an argument is, the terminology, premises that support a conclusion in a deductive or inductive way, the right vocabulary using strength and cogency versus validity and soundness, and then how to do propositional logic. But we're not there yet, so just kind of giving you a heads up of what the midterm will entail, what it will be about. Okay. So then for this exercise, I just had you look at these and try to figure out, comparing it to these argument forms right here. Right, which ones do they look like? It's a quick way, right? Like I said, this is sort of a heuristic device for being able to tell certain kinds of simple arguments that we rely on quite a bit to see whether they're right or wrong. And we rely on this kind of if-then reasoning a lot, and which is exactly why this is how computers work, right? Computers try to emulate human intelligence and human reasoning abilities, and computers are basically a bunch of instructions that say if A then B, right? And then you give some sort of input, and depending on the kind of input you get a certain kind of output. It's the same sort of thing that we're looking at here. We're basically trying to model human reasoning with these if-then type statements. You don't have to do it with if-then statements. It's just a nice way to do it. And we can have enough kinds of arguments that all start with an if-then, if A then B, right? Look at these 6 types of arguments that all have the same beginning premise. At least the format of the premise is the same in each case. Right? And people use these argument forms to reach conclusions. And sometimes that's the way they did that is fine, right? All the valid forms are fine. If you reason that way, you're being a reasonable, logical person. But if you use those first 2, the invalid ones, affirming the consequent or denying the antecedent, you're making a basic mistake. You're making a mistake in reasoning, right? The conclusion does not logically follow from those premises. So this allows us to just look at, as long as the argument is simple in that way, as long as it does just have, the first premise or one of the premises is an if A then B statement, and the other premise says something about the A or the B, right? If that's all there's to it, then very quickly, okay, there's going to just be a few different possibilities, right? And we also looked at the disjunctive syllogism, which is slightly different. But right now, just thinking about the if-then statements, right? You can see how we can have all sorts of arguments that begin with an if-then statement. Yes, Connie, thank you. Yeah, I did start it, but thank you for reminding me. I always want you to remind me. So thank you. So we did 1 through 3 in class, right? So let's do 3 again because it's so close to 4, but it's slightly different. Right? Socrates is Greek. And if Socrates is Greek, then he is human. So Socrates is human. So if you think, okay, well, let me put the if-then statement first. That's a little bit easier to track because that's the way we're going to look at it over here, right? So what's the if-then statement? If Socrates is Greek, then he is human. So if A, then B. And then it says Socrates is Greek. So it's saying A. Right? So it's saying if A, then B, A, therefore B. So what format is that? If A, then B. If Socrates is Greek, then he is human, right? If A, then B. Socrates is Greek, A, therefore B. Yeah, modus ponens, right? That's your basic valid argument form. So especially modus ponens and modus tollens, when it comes to the if A, then B, if you can get those in your head, If those are the valid ones, then you'll know that the other ones will be invalid, right? So that's number 3. Yeah, it's Latin. I don't remember what it actually stands for. Modus is mode, right? So it's a certain type of argument mode or form is basically all it's saying. It's this kind of format. Yeah. And notice, we talked about this last time, the valid ones get the fancy name, right? The invalid ones are named after what the second premise is doing. Yeah. So basically, while the meaning won't really help you in that sense, it's more, what is for the invalid ones, for example, the second premise there is saying B, right? For if A, then B, B, therefore A. So the second premise is affirming, right, the consequent. It's saying the second part of that if-then statement is true, right? Do you remember this part, right? If-then statements are called conditionals, and they have 2 parts to them, right? The first part and the second part. If A, then B, right? A is called the antecedent. B is called the consequent. Right? So if you look at that first invalid argument form, affirming the consequent, you can see that that's what the second premise is doing, right? It has in common with the valid and invalid argument form, this if A, then B construction for the first premise. But what is the second premise doing? Well, if it's affirming the consequence, right? If it's saying B, therefore A, that's a mistake. That's an invalid argument form. And if it's denying the antecedent, if it's saying not A, therefore not B, that's also invalid. So modus ponens, you could call it affirming the antecedent, right? Sometimes that would be more helpful because you could just remember what it's doing, whereas modus ponens doesn't really tell us that. I wonder if there is some sort of other mnemonic device you could use. I guess modus ponens, modus tollens, P comes before T. So if you think it's the P, then it's you're going to put the A first. Right? I don't know. That might not be helpful because then in the second premise you're saying not B. I don't know. Scratch all that. I was trying to help you come up with a mnemonic device to help you remember it, but I'm not sure if that works. If somebody can think of something based on the name ponens and tollens, if somehow that could help, there might be some mnemonic device for it. It's best just to know. It's not that much to memorize, is it? Right? Just these basic sort of constructions, and they have a fancy little name for them. A lot of science type mathematics. You're going to learn just new words, and you just have to sort of know how to attach them to the concepts. Turn it into a song. Yeah, that might work. Yeah. Okay, so 3 was just a modus ponens, right? If A, then B, A, therefore B. What about 4? It's very similar. You might be forgiven for thinking that if 3 is valid, then 4 will be valid as well. But that's why you take a critical thinking class or a logic class, so you'll learn that no, 4 does not work, right? So again, just try to put it into the formats, right? Do the if-then statement first. It says, if Socrates is Greek, then he is human. Right? If A, then B. Right, so Socrates is Greek is A, Socrates is human is B. Right, so then we're saying if A, then B. But then Socrates is human is affirming the consequence, isn't it? It's saying B is true, and then the conclusion says, therefore A is true. So if you were to write it all out in premise conclusion format, like I showed you how to do earlier, this would be helpful as well. Right? Lay it out in the premises and put that if-then statement first, and then see, well, what is the other premise saying about either the antecedent or the consequent? Is it affirming or denying the antecedent or the consequent? Is it, whichever it is? And then you can match it up to the correct argument form, and then you can quickly see whether or not it's valid or invalid. So it really helps to go through those steps that we went over earlier. Oh, my computer was not plugged in. So everyone sees what we're doing, hopefully, right? We're looking at these arguments and we're trying to reconstruct them either on a piece of paper, that's probably most helpful for you, or just if you can do it in your head, do it in your head. But basically try to see what the format of the argument is, and then you can just look at that format and see whether it's valid or invalid. Right? It's just a basic thing before we even get into doing logic and doing proofs and stuff like that. It's just a basic thing to get acquainted with. That just there's these 6 argument forms that you can quickly recognize and name, right? So I'm telling you, it's a heuristic device, right? It's something that you should just get in your head. These 6 different valid argument types. Now these are just 6. There's more of them as well. But I just wanted you to sort of be able to get that in your head so that when you see the argument form, you can quickly know which one it is. So 5, for example. 5 is a little tricky. Which one do you think it's most like if you had to pick one? Because I made sure that all the argument examples here would be one of these 6 argument forms. Yeah, when there's a lot of words, and that's why you break it down in terms of individual premises, right? Maggie's saying when you have just all this information washing over you, it gets confusing, and it gets confusing for anyone. A lot of times, even these simple ones will trip me up, and I think I'm good at doing them just in my head. They'll somehow just get jumbled and make a mistake. Yeah, so even for me, I have the same experience you have sometimes. It's very easy, but this is why you write it down. Right? Especially if you're taking a class. Now, maybe you won't do that in real life, but in a class like this, if you're looking at all these arguments and it's getting overwhelming, break them down like we went over, right? Putting it into premise conclusion format. That's the very reason that you do it, so that you don't have to deal with it all at once. You identify the conclusion, identify the premises, cut out the facts, and if you're dealing with arguments like this, find the if-then statement, put it first, and then ask yourself, what is the second premise doing? Is it either affirming or denying one of the parts of the if-then statements? Then you can quickly see which one it's doing and whether it's valid or not, right? Or perhaps, like in this case, as someone pointed out, it's a hypothetical syllogism where the second premise is going to be another conditional, and the conclusion is also going to be conditional, right? So it's something like, if technology advances far enough, then we will get teleportation technology. If we get teleportation technology, then our whole concept of transformation will have to be defined. Therefore, conclusion, if technology advances far enough, then our concept of transportation will have to be redefined at some point. Now, do you see how the last sentence, I switched it around, right? You have to understand that you can say an if-then statement in different ways. And sometimes people put the consequent first. Right? But you have to see the logical relationship between the antecedent and the consequent. So there's a whole little video just on conditionals. I'm not going to linger too much on all the sort of tricky and interesting things about conditionals, but at least check out the video so you can see a little bit what's going on with conditionals. They're quite strange sometimes. But they actually do make total sense once you get it. But here, so the tricky point was just, if you were to put this in argument, premise, conclusion format, when what's written is, so our concept of transportation will have to be redefined at some point, provided technology advances far enough. So provided there is just a synonym for if, right? So it's saying our concept of transportation will have to be redefined at some point if technology advances far enough. So if we then put it into our regular premise conclusion format using if-then statements, we'd want to switch that around and put the if first. We'll say, if technology advances far enough, then our concept of transportation will have to be redefined at some point. See how that works? Yeah. So just if it's something like this where I'm explicitly making sure that it's going to correspond to one of these basic argument formats, then then maybe it's a little more clear that you don't have to say provided, right? That means the same thing as if. But in everyday language, sometimes you'll put the if at the end of the sentence. When we're using conditionals, we just want to always say if A, then B. We want to put the first thing first. We want to put the antecedent first. Yeah. Because remember, the antecedent is whatever comes after if. So even if you have a sentence construction where you have the if as the second part, the part that comes after is still going to be called the antecedent because it's after if. Okay, what about number 6? If my car starts, that means I have gas in the tank. Since I don't have gas in the tank, my car won't start. Right, so the conclusion is my car won't start. The if-then statement is right there at the top, right? If my car starts, then that means I have gas in the tank. The second premise, there's a premise indicator, right? Since. So the second premise is I don't have gas in the tank. So what is that second premise doing? Well, it's denying the consequence, right? And what is denying the consequence? It's a modus tollens, exactly, right? If you look at this little spreadsheet here, if you look at the top right corner, if A, then B, not B, not A, therefore, not B, therefore not A. Right? Which basically, if you were to use the same language as for the invalid argument forms, you would call it denying the consequence. Right? Denying the consequent is valid, as long as you then deny the antecedent in the conclusion, of course. Yeah. Okay. So people got that one mostly right, I assume. Modus tollens. What about number 7? If my car starts, then that means I have gas in the tank. The same if A then B statement. But now it's saying I have gas in the tank, so my car will start. So what's that second premise doing there? Is it affirming or denying? And is it doing it to the antecedent or the consequent? Yeah, it's affirming the second part of the if-then statement, right? It's affirming the part that comes after then. I have gas in the tank, and is that valid or invalid? It's invalid, right? Well, yeah, right. In a disjunctive syllogism, you don't have that. That's right. And we did do a disjunctive syllogism. Number 2 was a disjunctive syllogism, right? So we didn't have any if-then statements to deal with there. So yeah, number 7 was affirming the consequence, which is invalid. Right? Again, you just, one of the premises is an if-then statement, and then the other premise either will affirm or deny one of those things. Then you know it's going to be, either a modus ponens, modus tollens, affirming the consequent, or denying the antecedent. So, as you practice these and get used to them, it'll become a bit more clear. It'd be nice if you could just sort of get this in your head, right? So you just know it. But at the very least, this is what you would have to study to do well in the midterm, right? Now, I'd rather you just do all these practices, and the people that show up for class do this more. If you're just watching the video, I'd still really recommend that you do the exercise, these exercises that we're doing, not just the ones that you get credit for. Right? It takes a little bit of practice to get this stuff in your head. Right? So, really quick, so just to look at the logic of it, right? I hope you see the difference between 6 and 7 just on an intuitive level, right? 6 is valid and 7 is invalid. And that makes a whole lot of sense. Right, let's say that it's true that if your car starts, you have gas in the tank. Right, so you don't have like an electric car or something like that. Right? Let's say you have a regular gas-using car. That means if it's starting, that means you have gas in the tank. Okay, and if you don't have gas in the tank, therefore that means your car won't start, and that makes sense. Right? We're already saying if it's starting, that means you've got gas in there. Right? So if it does start, it means you've got gas in there. What we're saying, you don't have gas in the tank, so it will not start, right? Premise 1, the if-then statement is basically saying your car won't start without gas. So that means if there's no gas in there, it won't start. So the conclusion there is just logically entailed by the premises, right? If both of those premises are true, if it's true that your car will only start if there's gas in the tank, but you don't have gas in the tank, what logically follows, what has to be the case, right, where you'd be contradicting yourself, right, if you said the opposite, your car won't start. Of course not. You just said your car will not start without gas, and you don't have gas. So then it logically makes sense, right? Supposing we lived in that world, right? Like I always say, you got to just think of the premises in some alternate reality if you need to. Let's suppose the world was like that, where both of those premises were true. Then it would have to be the case that the car won't start. Hopefully that makes intuitive sense, right? Whereas 7, it may be true that your car will only start if there's gas in the tank, right? If my car starts, that means there must be gas in there. That might be true, but does it follow that your car will start simply because there is gas in the tank? Well, no, because there might be some other reason that it's not starting. You see? So your car might not start at all, even though it's true that you have gas, and even though it's true that if it were to start, it would mean that there's gas in the tank. Right? Even if both of those premises are true, the conclusion could still be false. Your car might still not start. Whereas in 6, that's not the case. If those premises are true, the conclusion must be true. Right? So 6 is valid for that reason, because the truth of the premises entails the truth of the conclusion. Okay? Hopefully that makes sense. Okay, so let's do a little light intro to the next section, which is going to be propositional logic, and this all ties in together. So I'm leading you up to this, right? This is not a brand new topic now. I'm leading you into propositional logic, just slowly. Okay. So why do you do logic? What is logic as an activity, right? People have heard the term logic. You understand sort of what it means, maybe. But to get technical about it, it's really what you were trying to do is to provide some sort of proof, some sort of ultimate proof that an argument is valid rather than invalid. Right? That's what you're trying to find out. Is the argument valid or invalid? Right? So if we were to put this in terms of, as I've suggested, think of propositional logic as a game. That's the object of the game, right? I'll give you an argument format, right, with A's and B's and the symbols, and then the question is this a valid argument format, right? So if we're playing the game over here, this is pretty easy, right? Here you can very quickly say which ones are valid or invalid because you've learned to recognize the form, right, at least ideally, and you know what it's called. So you can very quickly, right, if this is all the arguments that I ever gave you to use logic to figure out validity, it wouldn't be that hard because we already know these argument forms. But we don't just have those argument forms. Arguments can get very complicated, and we don't have names for all of them. So then you use logic to figure out if they're valid or invalid, and you can prove it, right? You can, as much as you can prove anything in life, you can prove things in logic. Logic is very much like mathematics in that way, right? It's sort of this, we talk about how hard the sciences are, how scientifically rigid and how reliable they are, right? We tend to put social sciences as not very hard science, and physics is much harder, and chemistry and things like that. You could put mathematics below all of those as being very, very demonstrable and very well defined, and perhaps logic even underneath that, right? There's some disagreements amongst philosophers and mathematicians and logicians as to whether mathematics is ultimately just logic, right, or if it's its own special field. Some people want to argue that if you do logic correctly, you can actually get math out of it, right? It's a whole interesting subfield that you don't have to worry about, right? Here, my point was, what's the point of this game called logic? Well, you're trying to show if an argument is valid or invalid, right? Notice we're not trying to show that any given premise is true or false. That will just get pushed to the side for now, Right? The logic part of it has to do with whether or not the conclusion follows. And that's something that's independent from whether the premises are true or false. Remember that? Right? If I'm a wizard, then I know magic. I am a wizard, therefore I know magic. That's a valid argument form, even though one of the premises is false. Right? So you're going to have to get used to that idea, that validity is a matter of the argument structure. Right? Does it fit into one of these formats, or does it fit into another format that's logically valid, where you don't have to worry about whether the A's and B's are really true? You're just thinking about that sort of scenario. You're to say, well, if they were true, would this conclusion have to be true as well? Okay. So to do that, here are the pieces of the game, right? If we were to play Monopoly or Risk or chess or whatever it may be, if you don't know what the game is, then I'd have to show you sort of the pieces of the game and how they work, what the rules are. So that's what I'm doing here. I'm just giving you a couple of the basic elements of the game, basically. So it doesn't really necessarily have to make intuitive sense to you yet. You could just think, okay, I'm just explaining the rules of the game, right? And so I'm telling you, here's what we do. We use variables, right? We use A's and B's or P's and Q's. Doesn't matter. Theoretically, you could use an emoticon, right? As long as you're using the same one consistently. We use those instead of whole big sentences. Because, again, we don't need to worry about the actual truth value of the sentences, because we're just talking about logical validity, where we don't have to worry about what the sentences actually say and whether they're actually true or false. What we're worried about is the overall format of the argument and whether or not it's valid or invalid. Right? So we just get rid of whole big sentences and we just condense them down into a statement, right? Or into a variable, just an A or a B or a P or a Q. Right? And then we use these just four, right? You might be looking at those symbols and getting intimidated, but there's just 4 symbols, and actually you already know these. You already use these in everyday life, right? These are common sense concepts that we already use. So it's kind of nice. Once we go over it, hopefully you'll see that. Now, they do get more tightly defined than they do in ordinary language. In ordinary language, we're sometimes a little bit loose with our terminology. But in logic, we're going to tighten that up a little bit and really get down to what we mean by those concepts. The concepts and, or, not, and if then. Right. So far, we've seen examples of some of these. Right. We've seen if then type statements that we can go P arrow Q to represent. Right? And you've seen or statements, A or B. Right. We use the little V for that. And of course, you already know the ampersand, right? It just means and, like it normally does. Right? So we're basically using these, what we call them logical operators, but they're everyday concepts. They're just your word and, or, not, and if then. Right? It's just that we're going to really define those, say what the rules are for them, how they work, and then we can play the game with them. Yeah. So we'll go over that a little bit, but let me just give you some examples, right? What if we had this statement right here? Socrates is human and he is Greek. Right? Notice we're using one of those logical operators there, and. This is just a normal kind of English sentence, isn't it? We often use the word and when we're trying to say that 2 things are true. Right? We're not just saying that one thing is true, that Socrates is human, we're also saying and he is Greek. Right, so it's basically when you use the word and in that way, you're basically saying 2 different things. Right? And notice that each of those things can be true or false independently. Right? Maybe it's true that Socrates is human, but maybe he wasn't Greek. Right? Maybe he's Greek, but somehow, we're talking about a cat. Right? So you could see how in everyday language we already sort of do this. We take it for granted, but we have these kind of interesting constructions where you say a sentence like Socrates is human and he is Greek, and that whole sentence itself is going to be true or false. But notice that there's components of it as well that can be true or false independently of one another. Yeah. So it's a complex statement. Because we're putting together two simple statements. What are the simple statements? Well, Socrates is human. And if we're using what we learned in how to reconstruct arguments, remember we take out he and say Socrates instead, right? Socrates is human. Socrates is Greek. Two statements. Two simple statements, because those statements don't have the words and or not or if then or in them, right? So that makes them simple statements. They're not using those logical operators at all. It's a simple statement. Right? You could think of it as an atomic statement as opposed to a molecular statement. Right? You don't have to use that terminology. We can just use simple and complex. Yeah, P, and then the symbols that people use are different. Sometimes people use a dot, sometimes people use an inverted V. Okay, so that's kind of arbitrary. It's a little bit like you can have a chess set, and the queen might look different in that set versus yours, but functionally they're the same thing, right? So we are using the ampersand for and. Right? So when we say Socrates is human, well, we can make that into just the letter P. Right? Remember the variables, we use those for simple statements. So we could just have P be Socrates is human and Q be Socrates is Greek. And then we use the ampersand to say and. Right? So then we're connecting two simple statements into a complex statement. So what do we end up with? Well, pretty straightforward, right? P and Q. So instead of saying Socrates is human and Socrates is Greek, we could simply say P and Q. So notice the P's and Q's, what they stand for, what they represent, can't have any of those variables in it. The variables also always need to show up in the statement itself. Okay, that gets more complicated when you get more complicated statements. Right now, I hope that's clear, right? P stands for Socrates is human, Q stands for Socrates is Greek, and then we have the and symbol to put them together. Is that clear, I hope? Right? You don't have to know where this is leading, right? You simply, does this make sense so far, what I'm saying? Yeah, okay, good. Okay. Yeah, so you end up with P and Q. Right? Just like that. And notice there are different statements here that are true or false, right? Because you have Socrates is human, that could be true or false. You have Socrates is Greek, that could be true or false. And you also have the whole big statement, where the person's saying they're both true. Socrates is human and he is Greek. See how these are all slightly different? You could also say, in the same way, instead of using the and, you could have said, Socrates is human or he is Greek. That's a slightly different sentence, isn't it? It's easier to be right when you make an or statement, right? Because when you make an or statement, you're just saying, well, at least one of these is true. When you're making an and statement, you're saying that they're both true, right? You see that? So we're using the same the same simple statements, the P's and the Q's, but depending on what operator you're using, and this is true in everyday language as well. This is not just about logic. You already use these operators in this way. When you say that A or B is true, that's not the same as saying A and B are true, right? In both cases, you're using A's and B's, but you're saying something different. In one case, you're saying they're both true. In the other case, you're saying at least one of them is true. You could also just say Socrates is not human. Right? Then we're not turning it into a molecular statement, right? It's not composed of multiple statements. We'll still call it a complex statement because it's a simple statement with an operator. Right? So P still stands for Socrates is human. How would we symbolize, right? How would we use this logical notation to symbolize a statement like that? Well, you take the statement and you put a little negation sign. Like that little wave means not. Not P, right? It's not the case that Socrates is human, if we wanted to say that, right? So in everyday English, you say Socrates is not human. That's a normal way to say it. In logical notation, it's just this slightly awkward way of saying it, right? We're saying it's not true that Socrates is human, right? The little negation just means it's not the case. It's not true that whatever follows. Right? It's not P. It means Socrates is not human. If we had done a tilde with a Q, you could predict what that would be, right? Socrates is not Greek. Yeah. Or we could do an if-then statement, right? We've been using these if-then statements. And for that, we use this arrow, right? Basically, it shows you what we're trying to say. We're saying P always leads to Q, right? So we're saying if P is true, then Q is true. That's what the statement is saying, right? If it's true that Socrates is human, then it is true that Socrates is Greek. That's what the statement is saying. It's an if-then statement, and we just use that arrow to show this kind of logical entailment that we're trying to say. I mean, that's the basics of, just the basic pieces of the game. So if you start feeling overwhelmed, but also, it's all right. I mean, I'm teaching you a new game, and I've just shown you 4 symbols. And you actually know each of these symbols already, just by being a speaker of a language and a user of basic concepts. You already use these concepts all the time. Right? You might not be aware of it, but you do. And there's an internal logic to these concepts, these things that we're calling logical operators, and, or, not, if, then. But that's all the basic pieces. So once you get familiar with how they work, and I'll show you what I mean by how they work, but once you do, then you've got the basic elements of the game. Then, of course, you still, you can be good at a game or not as good, right? You can know all the rules of Risk but still not be that good. That's possible. But right now we're just at the rules stage, right? So you don't have to think that you know how to do it yet, but just look at these 4 basic concepts that we're going to use in propositional logic. So those 4 basic things, the variables, of course, that stand for simple statements. And again, simple statements will be little statements that don't have the operators in them, that don't have and, or, not, or if, then in them. Right? Those are the simple statements. And then we join those together with these logical connectives, these logical operators. Right, the 3 of them, we call them connective operators because they put P's and Q's together, whereas not doesn't join together multiple statements. It just goes in front of a variable. So it's slightly different from the other ones. But that's basically it, right? Variables that stand for short, simple statements, and then these 4 operators. So then those are the pieces, and like I said, you already know the rules. If you don't think about it, you already obey these rules. But let's make it explicit, and for that we're going to use what are called truth tables. Okay, so I'm going to pause the video so I can switch over. It'll take just a sec.